Let's go ahead and do another example of finding the optimum consumption bundle and total utility for a given set of information. And this is actually one of the problems in the practice problems, but we're going to go ahead and do it step by step in this particular lecture. So remember, there are only two questions I can ask you from a particular setup, and this is a very typical sort of problem that you're going to see on the exam. I give you two goods. We have root beer and candy right here. The prices of each of these goods, so root beer $1, candy 50 cents. So drugs and alcohol, always a good combination. And then here we have your income, $3. So we want to see exactly how you're going to use your entire $3 among both of these goods right here in order to maximize your total utility. So in order to do that, we have two goods. We have root beer, we have candy. We have quantity, total utility, marginal utility, and the marginal utility per dollar for each of these goods. And of course, as we sort of see within this particular sort of set of information, it's your job to fill out all the missing blanks in order to find and answer these two questions. So remember, the columns that we want to build up, the two most important columns that we want to build up are the marginal utility per dollar, as you can see right here. In order for us to see what the optimum consumption bundle is, we need marginal utility per dollar for both of these goods, the bang for your buck. This is exactly how we're going to be making this decision. However, in order to get marginal utility per dollar, we need marginal utility, which depends on total utility itself. So remember the equations that we built up with total utility, marginal utility, and the marginal utility per dollar. So here, marginal utility per dollar is change in total utility divided by change in quantity, and marginal utility per dollar is exactly that, just marginal utility divided by the price of the good. So here, this is exactly where we use these equations to full effect. Change in total utility divided by change in quantity, and this one's going to be just marginal utility divided by the price of the good. And in order for us to figure this out, we need to go ahead and fill out the blanks. So this is actually the most complete problem that you guys can see on any type of problem, where I only give you quantity and total utility, and it's up to you to figure out the next two columns. I could give you marginal utility, I could give you marginal utility per dollar right away, but as we can see right here, the way this problem is set up, this is the most complex and the most involved problem that you are going to face. So we need to build up the marginal utility, and based on the equations that we have right here, remember, change in total utility divided by change in quantity as we go from the first row to the second row to the third row, and then all the way down the line. We're never going to have any marginal utility or marginal utility per dollar for the first rows because it's quantity equal to 0, so we can just go ahead and put dashes right there. It's not available. So here we can go ahead and find the marginal utility as we go from 0 units of root beer to the first unit of root beer. So what's the change in our total utility? It's going to be 60 minus 0. 60 minus 0. And what's the change in our quantity? It's 1 minus 0. 1 minus 0. Simplify that out. Our marginal utility is equal to 60. And then we continue on this entire process as we go all the way down to the sixth quantity of root beer, the sixth unit of root beer. As we go from the first unit to the second unit, it's 110 minus 60 divided by 2 minus 1, and that's where we get 50 right here. But if you remember from the sort of setup or the information that we did in the previous lectures, the zigzag pattern is going to work out fairly well because we are going by quantities of 1. So 0 plus what number will give us 60? That's where we get that 60. 60 plus what number will give us 110? That's 50. 110 plus what number will give us 50? That's where we get 40, and then so on down the line. So here, 150 plus what number will give us 180? That's 30. And then you guys can go ahead, you can use the formula, you can use this zigzag pattern, whatever way is most comfortable with you. So we're going to get 20 right here, and then 10 all the way down. So as we can see, the law of diminishing marginal utility is still going to hold true with this example. Next step is to go ahead and find the marginal utility per dollar for this good. And marginal utility per dollar, that's the easiest one to go ahead and take a look at. We just take the marginal utility, all these values that we just solved for, and then divide it by the price of the good. As we can see right here, the price of root beer is equal to $1, so it's going to be the same exact value. So 60 divided by 1 is 60. 50 divided by 1 is 50. And then so on. So here, let me make that 60 a little bit better. So 60, 50, 40, 30, 20, 10. It's just dividing the same exact number by 1, so you're going to get the same value. So here we go, all the way down. And then that's exactly what we do for the very first good. And then we want to go ahead and do the same exact steps for the second good, for candy. Once again, what is the marginal utility for the very first unit? Do the zigzag pattern. What number plus 80 will give us 80? That's where 80 comes in. 80 plus what number will give us 150? 70. And then you continue down the process. This is going to be 50. This is going to be 30. This is going to be 10, and then this is going to be 10 as well. So here, As we go to 200 to 230 to 240 to 250, that'll be 10 in this instance. So as you can see right here, law of diminishing marginal utility still holds. It doesn't really matter that this is going to be sort of equal to one another. It's still sort of staying constant in this sort of case. So the law is still going to be apparent here. Last step is to go ahead and divide each of these marginal utilities by the price of the good. Price's candy is 50 cents, so that just entails multiplying each of these numbers by 2. So 80 divided by 0.5 is 160. 70 divided by 0.5 is equal to 140, and then down the line. So here, 100, 60, 20, and then another 20 in this instance. So here we've successfully set up the table in the manner that we need to do in order for us to go ahead and solve for the optimum consumption bundle. So remember the iterative step that we did with the pizza and wall climbing example. If you were the rational consumer in this particular example, where would you spend your first money at? You would go ahead and spend your first money at for your very first piece of candy because it gives you the most bang for your buck. You're comparing this 160 against the 60. You say, hey, my bang for my buck, the additional marginal utility that I get, the additional satisfaction I get for $1 is going to be bigger when I buy my first piece of candy. So I say, hey, my first money goes towards buying the very first unit of candy. Where's your second money going to go to? Is it going to be for another piece of candy, or is it going to be for your very first root beer? Here, in the same instance, you're going to want to go ahead and buy your second quantity of candy because 140 is bigger than 60, and then you put a 2 there. So your second money is going towards there. Your third money going to go towards candy once again because 100 is bigger than 60. And then you want to go ahead and say, hey, these two numbers are equal to one another now, so it doesn't really matter where I spend my next money. It could be towards my very first unit of root beer, or it could be for my fourth unit of candy. Let's go ahead and say that you just spend your next money towards towards root beer, and then your next money towards candy. It doesn't really matter which one you go ahead and choose first because these numbers are exactly the same. You are sort of indifferent from one another. And we can go ahead and check our maximizing conditions, our sort of utility maximizing rules. Number one, are we at a point where marginal utility per dollar is equal to one another? And yes, we are. 60 equals to 60, so we meet our very first condition. Are we at a point where we are spending up all of our money? So we spend, each piece of candy is 50 cents, so 50 cents, $1, 150, $2, and each root beer is $1, so that's $1 here. So $2 plus $1, that equals to $3, which is our entire income. So yes, we are meeting both of our conditions for utility maximization. So our optimum consumption bundle, as we can see right here, is going to be 4 units of candy and 1 unit of root beer. So here, the optimum consumption bundle is exactly this iterative process that we worked through. It's 4 candy, so 4 units of candy, and 1 root beer. 1 root beer. And this is exactly what you need to do in order to find the optimum consumption bundle. However, the second question that we can go ahead and ask is, what exactly is your total utility at the optimum consumption bundle? So a few different ways to approach this. We can take a look at the total utility for candy. We can go ahead and say, hey, my total utility at 4 pieces of candy is 230 utility units, or satisfaction units, happiness units, whatever you want to call it. And at 1 root beer, it's going to be 60 units of total utility. So you can just go ahead, go straight to the total utility at each of the respective quantities right here, add those two numbers up, and you will be able to get the total utility at the optimum consumption bundle. So total utility is equal to 230, because that's what we get from consuming 4 units of candy, plus 60, which we get for consuming 1 unit of root beer, which will give us 290 units of total utility. And once again, there is no other bundle that is going to go ahead and give us this amount of total utility where we spend all of our money. The other way to approach this total utility is to go ahead and add up the marginal utilities for each sort of respective quantity. So here we're consuming 4 units of candy. So when we add up 80, 70, 50, and 30, that's exactly where we'll get this 230. And then when we add up the marginal utility for 1 unit of root beer, we get that 60 right there. So once again, the sum of marginal utilities is going to equal total utility itself. So like I said before, this is the biggest problem that we can see within this particular chapter, where I just give you a few pieces of information, the prices of 2 goods, your income, something about total utility and the quantity, and you're going to be able to tell me what the optimum consumption bundle is and what total utility is as well. And these are some of the longest problems that you will face within this particular chapter, and actually for the entire semester. So I would highly encourage you to get as much practice as you can with this, because it will take up quite a bit of your time on the exams and for other assignments. So with this, you want to go ahead, get a lot of practice, make sure that you understand what type of information is being provided to you, and then you'll be good to go anytime you see these problems. You see, hey, I know exactly what steps I need to do. I need to find my marginal utility per dollar and find using the equations for marginal utility and so on in order to find my optimum consumption bundle. One further note that I want to talk about in terms of the utility maximization rule is, suppose that we are not actually operating at maximum. So something is actually telling us that maybe the marginal utility per dollar for one of these goods is greater or less than the other good. So what would we have to do in this particular situation? So remember that we had the maximizing condition of marginal utility of good A divided by the price of good A has to equal the marginal utility of good B divided by the price of good B. But what happens in this case if this is going to be greater or less than the other goods marginal utility per dollar? And intuitively, you already know what you should be doing in this particular scenario. So let's go ahead and write this down and see what we want to say in words. So just in full words right here. So let's go ahead and take a look at, suppose we are not at the maximum. So suppose we are not at maximum. So these two things are not equal together. So what happens if this is the case? The marginal utility of good A divided by the price of good A is greater than the marginal utility of good B divided by the price of good B. So what should you do in this scenario in order for us to be utility maximizing or to find the optimum consumption bundle? Should you buy more of A? Should you buy more of B? Less of A? Less of B? In this instance, remember, if marginal utility of A divided by the price of A, so the marginal utility per dollar, is greater, then you would want to go ahead and consume more of that good. So we can say at the very first step right here, we notice that 160 is greater than 40, so therefore you would want to go ahead and buy this particular good. So in this instance, anytime you notice that your bang for your buck for this particular good is greater than the other good, you should go ahead and buy more of that particular good. So as we've already noted in this sort of case right here, you want to go ahead and buy more of good A. You should buy more of good A, and less of good B, just in order for us to go ahead and utility maximize, find the optimum consumption bundle. If the opposite is going to hold true, then the opposite should be the case. If the marginal utility of good A divided by the price of good A is less than the marginal utility of good B divided by the price of good B, then you should go ahead and buy more of good B and less of good A. So should buy less of good A and more of good B, So if you know exactly what you should be doing in each of these particular cases if we are not at maximum. So basically the utility maximization rule, your bang for your buck, this is where it all sort of ties together. Like we said before, one of the longest problems that you're going to go ahead and see within this particular chapter. Get a lot of practice with it, and you'll be good to go with the questions that you're going to see on the exam. Only 2 questions come from this big setup: your optimum consumption bundle and the total utility at this optimum consumption bundle. And don't forget the 2 conditions in order for us to be utility maximizing. You have to spend all of your income, and the marginal utility per dollar has to be equal to one another. If not, then you're going to follow these particular rules in this case. I'll see you guys in the next video.